Have you ever wondered how a black hole, one of the most destructive and mysterious forces in the universe, forms? Science teaches us that in a cosmos where stars shine brilliantly, there's a dark side that few truly understand. A side where light is swallowed and space seems to collapse upon itself. If you think black holes emerge as galaxy-devouring creatures, it's time to rethink that belief. Let's unravel together the fascinating and unexpectedly logical process that leads to the birth of these cosmic giants. Get ready, because what you're about to discover may change your view of the universe forever. When people talk about black holes, the imagination often conjures up a colossal creature ready to devour everything in its path. But in reality, a black hole is simply what's left of a giant star after it collapses at the end of its life. This compressed mass generates a gravitational field so intense that not even light, the fastest thing in the universe, can escape. It's as if the universe created a natural trap, one where science is still struggling to understand all the details. Imagine a star so powerful that when it dies, it leaves behind a gravitational force capable of swallowing even light. An intriguing idea, isn't it? However, unlike what many might think, these black holes are not scattered throughout the universe like hungry monsters ready to devour us at any moment. They are rare and have a well-defined origin. They arise from stars that, after billions of years burning brightly, reach the end of their life cycle. Gravity wins the battle against the star's internal pressure, and the result is a black hole. So instead of being enemies of the universe, black holes are actually a natural and inevitable byproduct of stellar life, an important piece in the grand cosmic dance. The idea that nothing, not even light, can escape a black hole makes us question the nature of the universe. What happens to the matter and energy that fall into this cosmic abyss? Do they disappear forever, or do they transform in some way? These are questions that science is still trying to answer, and it's precisely this uncertainty, this open door to the unknown, that makes the study of black holes so intriguing. Science, with all its tools, is still at the beginning of its exploration of these cosmic giants. Now that we have an understanding of what black holes really are, we might ask, how do these intense gravitational forces align with the laws of physics that govern our universe? This transition leads us to reflect on gravity, a force we feel every day, but that around a black hole takes on truly cosmic proportions. Gravity, that invisible force that keeps us grounded, is the same force responsible for the existence of black holes. The law of universal gravitation, discovered by Isaac Newton, states that every mass exerts a force of attraction on another. The greater the mass, the stronger the force. Now, imagine a colossal star, with dozens of times the mass of our sun, compressed into a tiny space. This concentration of mass creates a gravitational field so strong that nothing can escape its influence. This phenomenon is an extreme example of how gravity works in the universe. To better understand, think about how gravity acts in our everyday lives. When you jump, Earth's gravity pulls you back down. Now apply that idea to a cosmic scale. In a black hole, gravity is so intense that if you tried to jump, you'd never return. This concept may seem abstract, but it's essential for understanding how black holes form and operate. Science, by studying these extreme forces, reveals the hidden complexities of the universe. Distance also plays a crucial role in gravitational force. The closer you are to a black hole, the stronger the pull. This is evident at the event horizon, the boundary of a black hole, where the gravitational force is so powerful that even light cannot escape. It's as if the universe placed a point of no return around these mysterious objects. This understanding of how gravity intensifies helps us realize that, although invisible, black holes exert a gigantic influence on their surroundings. Now that we understand how gravity shapes these cosmic objects, it's time to explore how they are structured. After all, what exactly makes up a black hole? How is it formed? And what are the parts that define it? This will be the next step in our journey through the fascinating universe of black holes. Unraveling the structure of a black hole is like trying to solve the most complex puzzle in the universe. A black hole is not simply a point of darkness, but rather a composition of elements that play fundamental roles in its existence. First, there's the event horizon, that invisible boundary marking the point of no return. Once crossed, not even light can escape. It's like a door to the unknown, where the laws of physics as we know them begin to break down. Surrounding this horizon, we find the accretion disk, a kind of ring of matter, spinning around the black hole at incredible speeds. This disk is formed by gas and dust that, as they are drawn in by the immense gravity, heat up to extreme temperatures, emitting radiation before being swallowed by the black hole. It's interesting to imagine that, although everything seems to be devoured by this cosmic giant, the accretion disk shines intensely, like a kind of last breath of matter before it disappears forever. Another intriguing part is the ergosphere, a region where space-time is so distorted by the black hole's rotation that nothing can remain at rest. Everything is dragged into a circular motion, as if trapped in a cosmic whirlpool. This phenomenon shows how black holes not only absorb matter, but also influence the very fabric of the universe around them. Science sees the ergosphere as a place where energy can be extracted from a black hole, a concept that challenges our traditional understanding of physics. These components work together, forming a system that is both fascinating and terrifying. But the structure of a black hole raises an inevitable question. What happens inside it? What are the mysteries hidden beyond the event horizon? To answer these questions, we need to explore the theories and mysteries surrounding these cosmic objects, which leads us to the next step in this journey. Entering the territory of black hole theories is like venturing into a minefield of cosmic mysteries. One of the most intriguing ideas is the possibility that these gravitational giants are actually wormholes, portals to other universes. If this hypothesis is correct, black holes not only destroy, but could also serve as gateways to parallel realities, completely changing our understanding of the universe. It's fascinating to think that a simple point in space could be the key to traveling between dimensions. Another mystery that leaves scientists puzzled is what happens to matter that falls into a black hole. Is it destroyed, or is there some kind of transformation beyond the event horizon? The theory of spaghettification, for example, suggests that any object approaching a black hole would be stretched into long, thin strips due to the extreme difference in gravitational force between the parts closest to and furthest from the black hole. Imagine an astronaut being turned into something like a strand of spaghetti. It's a scary image, but one that exemplifies just how extreme the forces at play are. Besides these theories, there's the intriguing question of the singularity, the central point of the black hole, where density is infinite and the laws of physics as we know them cease to function. Many scientists believe that within the singularity lies the answer to unifying gravity with quantum mechanics, the two great forces that govern the universe. However, understanding what really happens in the singularity is still a huge challenge for science, a true puzzle awaiting a solution. These mysteries and theories leave us on the brink of the unknown, but they also inspire us to keep exploring. And this exploration is not limited to the far reaches of the universe. It's much closer to us than we might imagine. Let's now take a look at the black holes that are literally in our cosmic backyard. When we look at the night sky, it's fascinating to imagine that hidden at the center of our own galaxy lies a supermassive black hole known as Sagittarius A Psi. This giant, with a mass of approximately 4 million suns, is the invisible heart of the Milky Way, around which all the stars, including our sun, orbit. It's impressive to think that the entire structure of our galaxy is, in a way, held together by the gravitational force of this invisible colossus. Science reveals to us that without this black hole, the galaxy as we know it might not exist. Although Sagittarius A Psi is the most famous, it is not the only black hole in the Milky Way. There are many others, smaller and less massive, scattered throughout the galaxy, each contributing to the balance of the cosmos in its own way. These stellar black holes are the remnants of stars that, at the end of their lives, collapsed under their own weight, creating these mysterious objects. Science, through careful observations, has found evidence that these black holes may influence the birth of new stars, showing that even in death, stars continue to shape the universe. The influence of these black holes in the Milky Way is, therefore, gigantic. They play a crucial role in the galaxy's dynamics, affecting the trajectory of stars and the distribution of matter in space. But at the same time, they are as mysterious as they are fascinating. How can these objects, which emit no light, be detected and studied? The answer lies in the advanced technologies that scientists use, such as observing gravitational waves and analyzing the motion of nearby stars, which reveal the presence of these cosmic ghosts. Understanding the importance of black holes in the Milky Way is just the beginning of a journey that leads us to question the very nature of the universe. These objects are not just destroyers, but also creators, shaping the cosmos in ways we are only beginning to understand. Have you thought about how these discoveries could influence technology or even our understanding of physics? Share your ideas and curiosities in the comments. And to stay updated on the fascinating world of the universe and beyond, subscribe to the channel and turn on notifications. Let's explore the wonders yet to come together.